Hello everyone. We have a definite integral to solve. As we see that the integral is too much complicated, so we will try to solve it by the method of substitution. If we let 1 plus 1 by t is equal to u, then u is equal to 1 plus 1 by t. Now differentiating on both sides, we have du is equal to derivative of 1 is 0, as you know, and the derivative of 1 upon t is minus t to the power of minus 2, because 1 upon t can be written as t to the power of minus 1. If we differentiate t to the power of minus 1 by applying the power rule, then we have d by dt of t to the power of minus 1 is equal to minus 1. Here the power comes down and we reduce 1 from the value of the power. So if we reduce 1 from here, then it will be t to the power of minus 1, which is equal to minus t to the power of minus 2. So we will use the derivative of 2 equals to minus t to the power of minus 2 here, dt, because the variable is t. So du is equal to minus t to the power of minus 2 dt. Now multiplying by negative on both sides, negative du is equal to t to the power of minus 2 dt. Now in the given integral, where the term minus t to the power of minus 2 dt is present, here we will replace the value negative du, because t to the power of negative 2 dt is equal to negative du, and 1 plus 1 by t is equal to u. But we see that the lower and upper limits are in term of t. We will also convert these values in term of the variable u, which we have substituted in place of 1 plus 1 by t. So now see, if t is minus 1, then what is the value of u? Let's see. T is equal to minus 1, then u is equal to 1 plus 1 upon minus 1, because by taking the value of t equals to negative 1, we have u is equal to 1 plus 1 upon negative 1, which is equal to 1 minus 1 equals to 0. So in place of negative 1, we will put the value 0, because when t is negative 1, then u is equal to 0. So our lower limit here will be 0. Now let's see for the upper limit. When t is equal to minus 1 by 2, then what will be the value of u? We have u is equal to 1 plus 1 upon t. So t is minus 1 by 2, here we will put the value of t, then u is 1 plus 1 divided by negative 1 upon 2. By simplifying, 1 plus minus minus 2, 1 minus 2 is equal to minus 1. So the upper limit will be minus 1. The integral will be now 0 to negative 1, t to the power of negative 2 dt is equal to negative u. So here we will put negative du, sine square u. Now rearranging it, 0 to negative 1, sine square u du. Now we have to evaluate sine square u. As we know that sine square u is equal to 1 minus cos 2u divided by 2 by using the double angle formula. 1 minus cos 2u divided by 2 du. It will be equal to negative 1 by 2, 0 to minus 1. We have taken just 1 by 2 common. So it will be 1 minus cos 2u du. Now taking the integral of 1 and then taking the integral of cos 2u, we obtain negative 1 by 2. Integral of 1 with respect to u will be u, and cos 2u, integral of cos 2u is sin 2u divided by the derivative of 2u, which is 2. Now lower limit is 0, upper limit is minus 1. As the integral is definite integral, so we need not to put the value of the constant of integration c, because here we have lower limit 0 and upper limit negative 1, which are definite numbers. So we need not to put a constant of integration. Now by taking upper limit first and then minus into lower limit. So first taking the upper limit, we have minus 1. Here put u equal to minus 1 minus sin 2 into negative 1 will be negative 2 divided by 2. Now put the lower limit, minus u is equal to 0, so it will be 0, and minus minus plus sin 0 divided by 2, because u is 0, so 2 into 0 will be 0. We have just taken the upper limit and then the lower limit. So by simplifying, we have minus 1 by 2 minus 1, as sine of negative theta is equal to negative sine of theta, so this negative will come out and multiplied by that negative, it will be equal to plus sine 2 divided by 2, and it is equal to 0 plus sine 0 is 0, so it is 0. Minus 1 by 2 minus into minus, that is equal to positive. Positive 1 by 2 minus plus minus sine 2 divided by 2 into 2, 4. That is our required answer. Thanks for watching the video.